welcome to the mathsonlinetuition.com videos where we go through the core books. We're starting off with C2 Chapter 1. So we finished C1. This is C2. All the videos from episode 1 to episode 15 are for C1. Let's get straight into this. Algebra and functions. Now with C2, because there's going to be a lot more information coming our way, and there's going to be a lot of information which we're trying to retain from C1, we won't look at C2 as in-depth as we did C1 for the simple reason that we don't want to overburden people with too many videos which are too lengthy, and at the same time we want people to think for themselves. The point of these videos is to give people an understanding, a basic understanding, probably scratching the surface of the principles and ideas within the content of the book, and for people to then go out on their own and revise this in their own time by doing questions. Again, if there are any problems, we do always recommend that people message us through the mathsonlinetuition.com website, and we're more than happy to help with solving the questions and queries. Okay, so as we said, algebra and functions. The graph of the cubic function must cross the x-axis once and therefore must have at least one root and factor. So we done cubic graphs in C1. Again, these are just examples of the different points at which the cubic graph can cross the x-axis. So simplify these fractions. 1.1. Essentially, in this part of the book, they're starting to get you accustomed to appreciating how to deal with equations which are not just linear or quadratic or cubic, okay, with a one denominator, but dealing with a fraction, and with that fraction, the numerator and the denominator holding different forms in terms of their powers. So we can see that for the first question, simplifying the fraction is as simple as breaking up each of the terms and separating them as different fractions. So here you have three different terms and three different fractions, so that will give away how many terms you should have, how many fractions you should have. And then to simplify, all they've done is cancelled out. So if you remember, we're just going to do some reminiscing here. If you go back to the rules of indices which we did ages ago, okay, you'll appreciate how important it is now to revise the material from beforehand. So remember, we said that XA divided by XB equals XA minus B. So here in this case, again, we'll get x3 minus 2x2 plus 6. Okay? And then once you've got all these terms together, then you can obviously see that they've combined them again to give us the simplified version. And they've done this for question B and question C. But question C, obviously, you've just got some negatives, so you've got to be careful. Simplify these fractions by factorizing. So look at what we have here. You can see that all they've done is essentially, for the first one, cancelled out the 2x minus 1 with 2x minus 1 on the numerator and the denominator. And for the subsequent questions, the following questions, they factorized this. Okay, now in this particular question, they've used the first method of factorizing, which is asking ourselves what number gives something which is multiplied by a and c, the coefficients a and c. Okay, what two numbers give us a and c, but at the same time add to give us b. Okay, so add to give us b. So here we can see that the two numbers that we have is 3 and 4. So 3 and 4 gives us 12, but at the same time also adds to give us 7. Okay, and likewise for C, they've used the same method. You get 5 and 1, and for D you have that they've obviously used 3 and 8. Okay, and then you can appreciate that now these numbers, okay, are getting more and more difficult. So you've got larger numbers here and probably more awkward numbers, so you have to be on the ball. Some exercises for you to do. And 1.2, you can divide a polynomial by x plus minus p. If you recall, in our C1 video we were discussing cubic, right? Cubic graphs, and we discussed in the cubic graphs that we would have ax cubed plus bx squared plus cx plus d. And in C1, a lot of the time, we had an equation which was cubic in its essence, but it was provided to us perhaps in this form. So for example, plus 3x plus 2. And because we knew what the root was, in this particular case, x minus 1, and we could factorize the quadratic to give us whatever x would be, it was straightforward. But we did mention that as we go along, we're going to be provided the cubic in its, what we would say, cubic form. So the equation as a cubic equation. Okay, now this is called dividing the polynomial. Okay, and it's a method that is very important for you to appreciate, and again, it's just something that you should know for C2. So let's go through it. So divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. So it's like long division. If you'll recall long division from primary school days, we have following: x3 plus 2x squared minus 17x plus 6. So the first thing we need to ask ourselves is as follows. Okay, how many times does x go into x3? Well, that's easy. X squared times, because if we multiply x by x2 we get x3. Okay, then we need to ask ourselves how many times does minus 3 go into x3? Right, well, we can appreciate that minus 3 does not go into x3. Okay, so all that we need to do now is drop what we have here, okay, by what we have over here. In other words, we would write x3 minus 3x squared. So you can see that we've multiplied x by x squared, and then we multiplied minus 3 by x squared. Okay, and then we do essentially a subtraction. We have 0, and then we have 2x squared minus 3x, which is going to give you plus 5x squared. And you bring down the rest of the terms. Now the next part, as you can imagine, is doing a similar process. How many times does x go into 5x squared? Now the reason why we're discussing this part here as opposed to just following on from here is because now we've addressed the first term, okay, and we've had an output of one term. This now becomes redundant because we've used it, and this is now the new term or the new equation that we are facilitated with, and we follow a similar process. I'm going to explain this again, perhaps in more clearer terms, using another example. So plus 5x, because if we multiply x by 5x, then we will get 5x squared. Okay, and now again we can ask ourselves the same question: does 3 go into 5? Does 3 go into 5x squared? No. So we essentially just bring everything down now. So we have 5x squared minus 3 multiplied by 5x. What is that? Well, that's going to give us 15x. Okay, So 15x, not the square root of x, which is what it looks like. Take away, so you have this minus 17x, okay, taking away minus 15x. So what's that going to leave you with? 2x plus 6. And then again we say to ourselves, how many times does x go into minus 2x? Well, we can see it goes into it minus 2 times. Does 3 go into minus 2x? No, it doesn't, because they don't share the same status, whereby this has a variable and 3 doesn't. So we ask ourselves, right, multiplying x by minus 2x, we got minus 2x, and minus 3 with minus 2 gives us plus 6. And you can see that if we subtract, we get 0 plus 0. So we have 0. Now here is the quadratic when multiplied with x minus 3, that will give you our original cubic equation, x to the power of 3 plus 2x squared minus 17x plus 6. And that's as simple as it is. Let's go through another example just to introduce this idea and firmly have it solidified in our head. 6x cubed plus 28x squared minus 7x plus 15. Okay, now divided by x plus 5. So same thing again, we have x plus 5, 6x cubed plus 28x squared minus 7x plus 15. How many times does x go into 6x cubed? Well, it goes into it 6x squared times. Okay, can 5x go into no, sorry, can 5 go into this? No. Okay, so we multiply now, 6x squared by x, we get cubed, 5 multiplied by that plus 30x squared. Okay, take away 0, take away, so we get minus 2x squared. Just going a little bit quicker now. X, how many times does x sorry, bring the rest of it down? Now we ask ourselves, how many times does x go into minus 2x squared? Well, we know it's going to be minus 2x times. Does 5 go into minus 2x squared? No. Okay, so now have minus 2x squared, and then 5 times by minus 2x, we get 10x. So we get minus, so take this away, this cancels out, and then we're going to have 3x plus 15. Once again, how many times does x go into 3x? Well, that's plus 3 times. Does 5 go into 3x? No. So 3x again, multiplying, and then 5 multiplied by 3 is 15, and we can see that's 0. So here is the equation, here's the quadratic. Okay, so this is very simple, very easy, straightforward, shouldn't be a problem. Here's another example you can do in your own time, and some more examples. Now, just a point to note here, you can see that we have the cubed, but we don't have the the squared. But we need to lay it out in order for our equation, in order for our calculations to run smoothly. So just because it's not there doesn't mean that we negate it altogether, doesn't mean that we ignore it. We have to also add it. Okay? And some terminology here. The number remaining after a division is called the remainder, which shouldn't be too difficult to remember. And the number that we have, or in our case, so the equation that we have in our case, okay, is a quadratic, is called the quotient, or the quotient, however you want to pronounce it. If we go into number 7, you can see that they've provided you with these two terms. Okay, now again, if you look at the question, you can see that they have 0 here and a 0 here, okay, minus 4x plus 4. So coincidentally the way the question has been ordered is such that the cubed and the squared goes together, so you bring down the remaining terms and you carry on the equation. Okay, so don't get confused between the fact that if there is no square root in the cubic, right, which some may think would mean to disregard the squared in the question. No, you'd have 0 multiplied by x squared. Okay, don't get confused with this question. The quadratic is there, the squared is there, but I'm just using it as an example. Okay, don't get it confused with the fact that if the squared is eliminated, if it's subtracted, if it disappears throughout the computations of the question, okay, that you re-add it. No, it's gone, and so you bring down what's left, the remainder, and you carry on your working out. And so again, you can see the same process is done here. The reason why they've stopped with minus 6 is because how many times does x go into minus 6? Well, you don't know what x is, it's unknown, so you can't go any further. So we stop and we say that the remainder is minus 6, which means that x minus 4 is not a factor of this cubic equation. Okay, so that means that if you were to put x is equal to 4 into this cubic, which is equal to 0, this would not be compatible. So 4 would not be a root of the cubic equation. And here is some other questions for you to do in your own time. And you'll see that you have hints here to help you along the way. 1.3. You can factorize a polynomial by using the factor theorem. If fx is a polynomial and fp equals 0, then x minus p is a factor of fx. Remember what we just mentioned? You shouldn't have forgotten, it was literally just 5-10 seconds ago. We said that if there is no remainder, that means that this is a factor of the cubic. So here they've used the algebraic division, which is what we literally just done. Okay, same rules apply. Here they use a factor method, so the factor theorem, where now you know that because you have the remainder equal to 0, that x minus 2 is a factor, so that means 2 is a coordinate on the x-axis, which is a root of the cubic graph. So we input it and you can see that we have 0. Now this is a verification method which you can use in an exam to make sure that your answer is right. So if in an exam it says to you, show that x minus 2 is a factor, okay, and you get 0, so and you get something other than 0, then you know you have a problem and there's something wrong in your working out. Or likewise, if it doesn't tell you it's a factor, if it says show that x minus 2 may or may not be a factor of a cubic, and you get a result, okay, say if that result was 0, if you take that number x minus p and you put p into this equation and you get other than 0, then you know that something's gone wrong. Okay, this is a good way to double check your answers. And here again they are just factorize this method, so write the polynomial as a fraction. This particular method is trial and error. You can see they've got minus 1, 1, 2, 3. Okay, usually in C2 the number will, most of the time in the sort of basic questions, the start off questions, the numerical number for representing the root on the x coordinate of a cubic will usually be between minus 3 and 3. They'll give you these terms in order to help you go through this sort of method of trial and error. Okay, so you can see here that when they've put 3 in place of x, that you have 0 as the result, and then if you factorize x minus 3, you can see we have 0 there. So again, this is just an example of how you can verify that you have the correct answer. And here you have an unknown. Given that x plus 1 is a factor of this equation, find the value of a. So you put it in, you know you're going to get 0 anyway because you've been told it's a factor, and then you can figure it out because there's only one unknown. And again, x minus p is a factor of fx, then fp equals 0. So essentially all they've done here is they've multiplied x minus p by gx. Gx represents a polynomial expression. Doesn't matter what it is at the moment, you just know that it's polynomial expression, and they've expanded it, substituted x to equal p, okay, gives you 0. So here you can see that 0 multiplied by gp means that we have 0, okay. And just to mention that point again, p and x are just variables representing any number which correlates with what you're trying to achieve, which is to show that x minus p is a factor of fx. So that means that fp equals 0. So we're trying to achieve that by replacing by saying that x equals p. So here's the exercises for you to do, and we go on to 1.4. You can find the remainder when a polynomial is divided by ax minus b. So this is a linear equation by using the remainder theorem. If a polynomial fx is divided by ax minus b, then the remainder is fb over a. So you've got this working out here following a simple method, the algebraic division, and then you've got the remainder method, and you can see the same process here. But what's important to highlight, which is written on the side of b, is write the polynomial as a function, use the remainder theorem. If fx is divided by ax minus b, then the remainder is fab. So compare x minus 4, so we have here that a is 1, and we have here that b is 4, so the remainder is 4 over 1, i.e. f and 4, so you substitute 4 in place. So this is just to get you appreciating the different ways of resolving the questions, okay, and you can appreciate these different methods to verify your different techniques. If you were to get minus 13, okay, and you want to know what the factor, not the factor, but what was the perhaps divisor, okay, of the cubic, then you would say, right, sorry, rather if you want to know what the remainder is of the cubic, a shorthand way of doing so is saying 4 divided by 1, which gives you f4, plugging 4 in there, you'll get 13, okay. And it's simple to see with x minus 4 in this particular case, but if you had, for example, 2x minus 4 and you wanted to know what the remainder would be, then you would say 2 is a and 4 is b, then you'd get 2, so f2, and then you'd plug it in there, and whatever answer you got, that's the remainder you'd get should you have, if you had used 2x minus 4 and divided it by the cubic, okay. And see here now you can get a different you can just get another example. So I have exercise to go through on your own good time, a mixed exercise, and then the summary of key points. Please read through this, please familiarize yourself with it, and that's the end of chapter 1 of the C2 book. Like I said before, we're going to go through this book a lot quicker and skim through the surface to give you a basic idea of what you need to do without going into too much detail, because there will be too much information to discuss. So thank you very much for listening. We hope to see you for our next video. Take care and bye bye.